Welcome to section 10.2, part 2, graph y equals ax squared plus bx plus c. Before we start with this, we're going to clear up any misunderstandings that you might have from the first lesson. So just remember that a quadratic function equation is y equals ax squared plus bx plus c, where this a, that b, and this c are all numbers. So we also have the quadratic function equation right there. So we're going to start with number 1, where y equals 2x squared minus 3x plus 6, where our 2 is the a, because the 2 is attached to the x squared, and so is the a. So the a is 2. Our b is attached to our x. So our b here is negative 3, and finally our c is our 6. We're going to do the same thing for number 2. Here again, what is attached to the x squared? What is attached to the x squared is the negative 3, or the a. So our a is negative 3. Our b is attached to our x. Here, what is attached to our x? 4. So here, b is 4. And now c. Is there any c? Is there any number added in this equation? No, there is not. How do you represent nothing in math? Well, you represent it with a 0. Next, we're going to touch on the steps to graph y equals ax squared plus bx plus c. I know you already have these in your notes, but we're going to go through them really quickly one more time. First thing you do is draw the axis of symmetry, where it is x equals negative b over 2a. Next, we plot the vertex by plugging in x, or negative b over 2a, into our equation that is given to us. Next, we choose 2x values less than the x coordinate of the vertex. 4, we determine if the parabola opens up or down. 5, then we reflect the points that we picked. We reflect the points that we picked over the x-axis. And then finally, probably the funnest step is to draw the parabola. So we're going to go over one more example just to make sure that we have everything down. So the first thing that we're going to do is find the axis of symmetry. Remember that the axis of symmetry is negative b over 2a. So now that's a big step here. So we have negative b, which is negative 4 over 2a, so it's 2 times. And now what is our a? What is our a from this black equation right here? Well, there's no number in front of x squared, so I can know that the number is 1. So we keep going. Negative 4 divided by 2. That is going to be negative 2. Now, for the next step, we plug this negative 2 into this x. Plug this negative 2 in for this x and that x. So let's try it, and I'm going to use a little different color. So we have negative 2 squared plus 4 times negative 2 plus 8. You punch that into your calculator, and that will give you 4. So now we know that the axis of symmetry is negative 2. So I'm going to draw my axis of symmetry at negative 2. Then I also know that my vertex is at negative 2, up 1, 2, 3, 4. I'm going to put a point right there. Now remember, we're going to pick 2 more points that are below negative 2, and I'm going to pick point negative 3 and plug that in for x, square it, plus 4 times, again putting it in for x, plus 8 equals 5. Then I'm also going to pick one more point, and that point's going to be negative 4 squared plus 4 times negative 4 plus 8. You punch it all into your calculator, and you get 8. So now the first point I picked was 3, or I put in negative 3 for x, and I got 5. So I'm going to go over from my origin, 1, 2, 3, and then go up 1, 2, 3, 4, 5. Plot my point. And then the second point I picked was -4. So I'm going to go over -4, 1, 2, 3, 4, -4. Then what did I get when I plugged -4 in? I got 8. So I'm going to go up 5, 6, 7, 8 and put a point. Next, I'm going to translate my points across the x-axis, so I went, or across the axis of symmetry, so I went 1 to the axis of symmetry, so I have to go 1 away. And then at this point, I went 2 to the axis of symmetry, so I have to go 2 away and plot my point. Looking at our equation here, should this open up or down? It opens up because this is a positive x squared, so my points are going up, so therefore I know I graph my points right. And then everybody's favorite part is to connect the dots, so let's go ahead and connect the dots as best as we can. And there's our parabola for y equals x squared plus 4x plus 8. Now again, I want to remind everybody of maximum and minimum values. When we have y equals ax squared plus bx plus c and a is greater than 0, we have a parabola that opens up with a minimum value, and we have a parabola that opens down if a is less than 0, and we have a maximum value. And now remember, our vertex is going to be our highest or lowest point on the graph. The vertex is the highest or lowest point on the graph. Finally, that brings us to everybody's favorite word problem. So the suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by the graph of y equals that equation, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? So the key words here are lowest point. What is the lowest point? Well, the lowest point is the vertex, but first we have to find the axis of symmetry. So I'm going to find the axis of symmetry, and I have a negative. Here's my b. All right, there's my b. A negative 0.37 over, whoops, that's an ugly line, 2 times 0.00097. And now you can just plug that into your calculator, and you will get 1910, and now that is our x value. We only found our axis of symmetry, so now we have to find our vertex by plugging in this number in for all the x's. So let's go ahead and try it. We have 0.00097 times 1910 squared minus 0.37 again times 1910 plus 549. And now you can punch that all in your calculator, and we get 196. Now what is 196? Well, we found that the lowest point, so our vertex is 196 feet above the water. Why is that? This is our y value, right? Y's run up and down just like the cables would above the water. So we know that the cable, the lowest point of the cable is 196 feet above the water, and that concludes the lesson for 10.2 part 2.